In this video, we'll be talking about a special formula for finding the inverse of a 2 by 2 matrix. So there is a useful shortcut for finding the inverse of a 2 by 2 matrix, namely for a 2 by 2 matrix of the form A, which is, here's the entries A, B, C, and D. A is invertible if and only if AD minus BC is non-zero. Moreover, when it exists, the inverse is actually given by a scalar multiplication of 1 over AD minus BC times the same matrix A, B, C, D, except that now we've swapped A and D and we've put negatives on B and C. And here, the denominator AD minus BC that we saw show up here and here is called the determinant of the 2 by 2 matrix A. So a couple of things. First off, we will see determinants much more in a few more videos when we start talking about section 8.4. But in the meantime, just kind of put a pin in that. They actually tell us a lot more than just the inverse. But here we can think of it as sort of, does it determine whether it's invertible, whether a 2 by 2 is invertible or not? And here, it becomes pretty clear why you need it to not be 0, because in this formula, if there was 0 here, you'd be dividing by 0. So let's do a couple of examples of finding the inverse of 2 by 2 matrices using this formula. Here, first, let's go ahead and calculate the determinant to make sure that it does in fact exist. Here, if we go through and calculate the determinant here, first let's go ahead and calculate the determinant to see if it's if the inverse exists. So here we have 3 times 2 minus, and I like to think of it as multiply those two and subtract the multiplication of those two, because that's what you're doing. And so we get 3 times 2 minus negative 2 and negative 1. Doing so, that's going to be 6 minus 2, which is positive 4, which the point is that it's not 0. All right, so A is invertible. And it's worth calculating that anyways, because you're going to need it for the inverse. Namely, A is going to be 1 over, I'll write it out, AD minus BC times, we swap A and D, and then we put a negative on the B and C terms. Here we already calculated that as 4, so that's 1/4 times D gets moved there, A gets moved down, put a negative on C, you get positive 2, negative on negative 1 gives you positive 1. In other words, we have the following as the inverse. We have 1/2, 1/4, 1/2, 3/2 as the inverse. Now for B, for the matrix B here, we have that if we calculate the determinant out, we have 3 times 2 minus negative 1 times negative 6, which is 6 minus 6, which equals 0. And since it's 0, B is not invertible. So that's a useful trick for finding the inverse of a matrix, of a square 2 by 2 matrix. Now it's your chance to try out an example. So go ahead, if possible, find the inverse of the following matrix A. On the count of 3, I'll reveal the solution. 1, 2, 3. So here we see that we get 23 for the determinant, namely, since that's non-zero, A is in fact invertible, and there would be its inverse. For more practice in computing the inverses of 2 by 2 matrices using that formula, be sure to see the textbook pages 574 and 575. In our next video, we'll revisit systems of linear equations with this sort of algebraic understanding of inverses.